What's up, everybody? Welcome to System Crafters Live. I'm David Wilson, and we're back again with another Friday stream where we get together as a community and talk about whatever topic I came up with at the last minute as a result of a Mastodon thread this morning, which is just how it tends to happen. Thank you all for being here today. Excited to talk about the topic. But first, let's say hello to the people who are here so far. If I can get the things pulled up, I see Ashraz and Ramin. And MG Delacroix, Dean. Good to see you, Ramin. And it's all Ramin's fault that we're talking about PreScheme today because Lewis was talking about C3 on Mastodon, and Ramin reminded me of PreScheme, which I haven't actually taken a look at on the channel yet. So that's what we're going to do today. We're just going to take a little look at PreScheme. I'll talk about it more in a second. Who else we got here on the IRC side? Let me check the other machine. I see John Hamelink earlier on. I see Robin. Hey, Robin. Judy, Jeff, Pie the Sailor, Mike. I think Cal 2001 is somewhere around. All right. And Shom. Nice to see you, Shom. There seemed to be quite a lot of interest in the stream today, so I'm kind of excited to talk about this topic and see how people feel about it. You know, it's been a little while since I talked about Scheme on the channel. I think I got a little bit of Scheme overload in the first 6 months of the year because I, made a whole Scheme course, delivered it a few times, was writing a lot of Scheme code for various different things, game jams, etc. I was like, okay, let me just take a little break and refresh the mind a little bit, and then come back to the fresh pair of eyes. And that's basically what we're going to do now. I'm just going to take another look at Scheme through the lens of PreScheme. Let me see what the stream is doing okay. It's a little bit choppy. Anybody notice choppy video in the stream? Or is it just me? Let me see what the... Okay. It looks okay on OBS, but maybe on YouTube's not so good. Mike says, Scheme overload? No way. Oh, yes way. Ashra says, other machine? Maybe a tablet that shows all chat streams would be helpful for you. Live coding session next week. Live coding, I would love to do some live coding again. I've actually been getting the live coding itch. I'm kind of wondering, wow, it is choppy, isn't it? What's going on? I'm getting the itch to do a game jam again, but it's not really, trying to understand what's happening. There's no good game jams coming up soon, I think. Sorry for the choppy video. I have no idea what's happening. On Twitch too, must be my computer. I think OBS must be just eating all of the CPU. And that's okay. That's okay. You're not here to see my head moving smoothly in 1080p. You're here to see Scheme. So that's what we're going to do. We're going to get back to the Scheme. So, hey Big Edie, nice to see you. Let's talk about the news real quick. First of all, I will remind you once again, as I have been doing for the past few weeks, about the Emacs Conf 2024 call for participation. This is basically a call for proposals for the Emacs Conf. The actual talk length for Emacs Conf is pretty short. It can be anywhere from like 5 to 20 minutes, maybe more. If you beg Satachua, maybe she'll give you a larger spot. I don't know. But for me, 5 minutes is probably enough. I could not possibly do a 20-minute talk. It's not like I talk extemporaneously for 2 hours every week or anything like that. Point being, I think that it's going to be a great event, as it always is, and you should consider submitting a proposal for a talk about any Emacs-related topic that you are interested in. and see how it goes. I still need to submit mine. I don't know what it is yet. All my ideas are going into YouTube videos right now, thankfully. So we'll see if I come up with a topic that is worthwhile for us to see at Emacs Conf. But I suggest that you do it, though. You should definitely submit a talk for Emacs Conf. And that's as much as I'll say today, because I've said enough about it recently. Next week, I am planning to release another System Crafters video. That will be 3 videos within 2 months. That is breaking a record for the last 2 years, so I'm very proud of myself for having some level of consistency recently, because there is a dark period there between 2022 and 2024, beginning of 2024, where not much happened because life had to readjust to moving to another country and dealing with a whole host of problems. But now I have nothing to complain about. There's plenty to complain about, but I don't really have excuses anymore. So I actually have to make videos. Yes, that was a big topic. Thanks for reminding me, Big Edie. So Athens basically burned down this week. Last week, as you probably know, I was out for vacation. I was on the other side of Greece in the Peloponnese, taking a week off with the family, going to the beach every day. Probably can't tell that I have a little bit of a tan right now. Doesn't really matter. Point being that we had a nice time, and we came back home on Sunday, and we noticed when we came back home that the sky was full of smoke in the mountain that's right next to our house. So the next morning, the fire had progressed quite far from its original location, which was not too close to our house, but then it started getting much, much closer. So we actually had to evacuate our house on Monday and pray, in a manner of speaking, that our house would not get burned down. Thankfully, all that is resolved now. The fire was put out, but it got pretty close. I mean, it wasn't like next to my house, but it was close enough that it was quite uncomfortable. So thankfully that was taken care of, and we're all good. So I'm back in the house, doing the normal thing. But it goes to show you, don't live in a country or a state, if you're in the United States, where there's a lot of dry plants and people who like to set fires, because apparently that's what happens. People just go set fires on purpose, and then it just burns like the whole country. Smart people. Anyway, that's that. That was quite an adventure. All right. Big Edie says, your last couple of videos caused a bit of a stir on Reddit. Comments? Not really. I just feel like people are a little bit too strict about what a video should be sometimes. And I don't know. I don't really care, dude. I mean, if most of the people who see the video tell me they like the video, that's all that matters to me. And also, not everyone, this is just a general statement to anyone out there who likes to be really critical about things that other people create. Not everyone knows everything that you know. So you might be able to learn something really fast by looking at some piece of information on the internet. Other people don't have all the context that you have. So maybe a person having a video that explains things to them and gives them use cases for why they would want to do something, it actually be kind of useful, and they might learn something from that. And maybe they're willing to tolerate some admissions that they don't know everything about the topic, but the person's just sharing what they know. I feel like that's a reasonable thing to do. This is the internet. I'm not saying that I am the world's foremost expert on everything about Emacs. I'm just a person who's sharing what I'm learning and giving it to other people. So it's okay. I don't care. I didn't engage in the conversation further because it's a pointless thing to do. Don't feed the trolls, as they say. So it's all good. I'm making more videos, and I'm gonna make them more shitty than the last one. So that's what's gonna happen. All right. Dave says, haters gonna hate. Hey, Dave, you're right. That's basically what's gonna happen anytime anybody puts themselves in the public. I haven't really received a whole lot of hate on this channel, and I wouldn't really say what I received was hate, just criticism, which is fine because everybody has an opinion, but, it's just the name of the game. You put yourself out there, you're gonna get comments. So let's see. Have I been reading the comments again? Well, I mean, if you post something to Reddit, you will end up seeing comments. The tyranny of the opinionated audience. I think that at some point, every audience becomes opinionated. Hey, shit wizard. Hey, Minas Mazar. And Andrea. Andrea says, did I miss something? No, not really. Ramin says, I really want to present at Emacs Conf 2024 this year. I will submit my proposal within a few weeks. You should. Oilad says, arrow keys, use the mouse in the menus. Yeah, that's what I'm going to do. I'm going to make a new video talking about why you should not use Emacs key bindings. You should only use the mouse and the right-click menu. I won't get the Golden Raspberry Award for my videos, Gun. Hey, Gun. I should probably try a little bit harder, though, if I do want to get that. Okay. So, yes, new video next week on org agenda bulk actions. So basically following on from the org agenda video from last week. Yeah, last week. How do you do certain or perform certain actions across multiple to-do items that are in your org agenda? I feel like that's kind of a useful thing. Shom says, Dees Thompson, this is Scheme Central, not Swiftlang. Swifties in the chat. What are we talking about here? All right, so today, what I want to do is talk about a really cool project called PreScheme. Now, this is not a new project. It's actually something that's been around for a very long time. It's actually one part of a Scheme implementation called Scheme 48, which is quite old, actually. I was reading some background info about this on Wikipedia today, and the first release, or it first appeared in 1987. And it's basically a bytecode interpreter Scheme implementation, which is pretty common these days for Scheme implementations to be a bytecode interpreter. You know, you basically have a compiler that does some transformations to the Scheme code, turns it into bytecode, and then executes it, or maybe even uses a just-in-time compiler to turn it into native code. Guile does this, many other kind of high-performance Scheme implementations, and obviously other language implementations do this. So not so special from today's point of view, but maybe back in the late 80s, it was something. It's actually funny. I don't know if it was here. Yeah, I think this article by Olin Shiver's History of T on Paul Graham's website actually goes through the history of some of this work. And it was kind of funny how he mentions that I think Jonathan Rees is one of the authors of Scheme 48, was talking to Richard Stallman and some other implementers of Lisp implementations. And they were basically saying, yeah, I don't want to add lexical scoping to my implementation because it's too slow. Well, I guess people didn't really understand the optimizations you can actually get from lexical scoping in a compiler until later. But anyway, if you like sort of language development background, this is probably a good article for you, but we're not going to go through that. That's not really the point of the stream. The point of the stream is to talk about PreScheme, which is a dialect of Scheme with some special qualities. So I believe PreScheme was developed in Scheme to be something that translates Scheme code to C, to be compiled into a native application. So you could basically write native programs in Scheme, but it's not the normal Scheme that you would see if you just fired up the Guile REPL and started defining procedures. This is actually a custom dialect that has static typing, which you kind of need if you're going to do native programming, because you need to define what the types are for the different pieces of information that are being passed through functions, or in like a structure that is going to be kind of a composite piece of data that's stored in memory. So like when you have the C language, you have to say that something is an integer or a short or a char or char, or a float or a double or whatever types that are available there, or even a struct, which is comprised of fields of the different core types or other struct, etc. So the compiler needs to know the size of the pieces of information that you're storing in memory. You don't really have that with a dynamic language, more or less dynamic language like Scheme or Common Lisp, etc., because the way that the information is stored is a bit different. You can have the information stored in one location in memory, but generally you're not like allocating different size objects for things that could be smaller. You're allocating the same size object for most of the core data types, and then you have pointers to things that are on the heap instead. Can't have that if you're doing native programming. I guess you could have that technically speaking, and there is the concept of allocation for PreScheme, at least based on what I've looked at in the documentation. But it's the difference between automatic memory management, which is in a dynamic language that's garbage collected like Scheme, and then manual memory management in a language like C, or in this case like PreScheme, where you have to be explicit about the sizes of things that you're allocating, and also have to manage the memory yourself. So keep in mind that the whole goal here is to cross-compile, let's say, Scheme code of a specific dialect from Scheme or from PreScheme to C, and then compile that with a C compiler. This is not really a surprising thing. I mean, I'm sure that many Scheme programmers who want to use Scheme to write native programs have thought about this. In fact, Christine Limmer-Weber wrote a blog post called Guile Steal at some point in the past, a proposal for a systems Lisp, which is basically going through the same idea. Why can't we have a Scheme that you can use to write native code? I've also thought about this myself at times. Many other people have thought about this. But it turns out there was always PreScheme, which predates many, many things. So we're going to take a look at that today and actually see if you can write something, I wouldn't say non-trivial, but more than just plainly trivial. What I would like to try to do is learn enough about PreScheme to try to write a very simple Raylib application. I don't know if you've heard of Raylib. Maybe you have. It's starting to get a little bit of buzz, Raylib. It's a kind of a game library that is easy to get started with, really simple C API, easy to bind to from foreign function interfaces. So I've recently did some development with Chibi Scheme, where I embed Chibi Scheme into a C application, and then I use their stub generator to generate stubs for Raylib APIs from Scheme to C. With PreScheme, in theory, I should be able to generate stubs, but it all gets compiled into a C application directly, and I have more control over the memory allocation, etc. So we'll see what we can do. I mean, really the goal would be to get a window up on the screen, maybe draw a square that moves around, something simple, and just see how far we can get with it. But I feel like that's a good test program to give it a shot and see if we can get some C out of the PreScheme. So let's see what we got here in the chat. Robin says T is amazing. I have not looked at T, but I saw it getting quite a lot of love in some of the things I was reading. So pretty cool. Gunn says, why bother converting the language? Write a Lexer parser and compiler for Scheme itself. I mean, certainly you could do that, and it would be fun to do that. I mean, anybody who has gotten into writing Scheme compilers is probably itching at the idea of writing a, native compiler direct from Scheme to, x86 assembly or something. But that's not really the most efficient use of one's time, I think. And this is why I'm trying to stay away from compiler authoring now, because I realize that it's a very, very deep rabbit hole, and it's kind of hard to come out of it. That's kind of why 2023 got lost for me, because I got a little bit too deep into mesh, and it was kind of 2022, 2023 on and off. It's not good. It's not good. It would be good if you're working on something that people are going to use, but if you're just hacking on some project for fun and you get sucked into it for 9 months, maybe you got to rethink it a little bit. I don't know. So that's not to say that I won't ever look at mesh again, but I got to be careful. Case says there's also Loco Scheme. Yeah, Loco is definitely a direct to native, but it's like bare metal native, not even like to C API or anything, right? Just real bare metal. Let's see. Shom says his game stub sounds like it's going to be a hoot. Well, let's see. Big Edie says we love mesh. Yeah, I got one user. That's me. C-Mac says, feeling seen, got to get my MC Clim backend finished. Yep. Yeah, it's how it goes. All right. Hello to Naokotani over on the YouTube side. I see you there. And the Kites. Yeah, Kite says it's called Scheme 48 because the first version was written in 48 hours. I mean, are we really trying to liken a Scheme implementation to a cheesy Nick Nolte film? I don't know. Kay says, I want to get hardcore into McClem too. How do you pronounce McClem? Is it McClem? Is it the new yearly 1 month special food item for McDonald's, the McClem? Just slathered in barbecue sauce and kind of crunchy because it's made out of ramen noodles. That would be pretty cool though, actually, wouldn't it? Like if you just went to McDonald's and the new hot food item was an uncooked brick of top ramen with just barbecue sauce all over it. Sorry. I know I'm just inventing new horrors here, but I gotta go where the muse takes me. McLean. CMAX says, what is happening? I get that question a lot these days. I'm sorry. I think I have brain damage. I don't know what to say. Yes, Ramin says, I saw that film with Nick Nolte and Eddie Murphy. Yeah, it's pretty good. I'm just kind of joking around here. Purple Cheese says, David is unhinged now. Yes. That's what happens whenever you stop writing scheme code. Your brain has to invent new ways to entertain itself. And you just start saying a bunch of random stuff. The McClem is back. Only at McDonald's. This stream sponsored by the McClem. The most horrible thing was hearing Raymond. Yeah, I'm from the Southeast United States. We don't know how to pronounce things. Okay. So Scheme 48. Where was I? So Scheme 48 uses a virtual machine to interpret the bytecode, which is written in a restricted dialect of Scheme called PreScheme. So basically, they've bootstrapped their Scheme implementation using a dialect of Scheme that is interpreted by their Scheme implementation, which transpiles to C. So they've solved the whole bootstrapping problem, which, yet again, is another thing that every Lisp implementer wants to do. Well, I didn't want... So, okay. Let me just give you a reason why I would say Raymond here, because I didn't want to confuse everybody with Ramen or Ramin who's in the chat. I know it sounds weird to say that, but, you know, I have my reasons, please. Case says, I'm from the Southeast, David. I can say ramen correctly. Good for you. Good for you. I'm very proud of you, Case. You're actually educated in the English language. I'm not. All right. So PreScheme is a statically typed dialect of Scheme with the efficiency and low-level machine access of C while retaining many of the desirable features of Scheme. I think I had started saying before that there are other Scheme implementations that compile to C, like Gambit Scheme, but it's not the same because Gambit is actually taking the runtime of Gambit and baking it into a program. So it's still doing garbage collected, dynamic memory allocation, etc. on the heap. But you're getting a compiled program out of it. So it's just taking Gambit Scheme and turning it into C code that just bakes everything into one executable. So this is different. This is actually writing code that is more akin to writing a C program. But once you see the output of the compiler into C, you will see that it's not just plain old C code. I mean, there's some stuff happening there. There kind of has to be stuff that happens there because we're still injecting some Scheme-like functionality. There's even tail call optimization in certain parts, and you can define record types, I believe. So there's some level of translation that has to happen. It's not just like a pure Scheme to C transpilation. You have some kind of bookkeeping, etc. needed. I believe we're gonna see in a moment. Ramin says, my nickname in junior high school was Noodles. That's not very nice. I hope it was a nickname that was given in love and not in jest. Big E says, sorry, I might have missed this. What's the benefit of to converting to C rather than compiling directly? That's a great question. It's very difficult to write a direct-to-native compiler that is as good as a C compiler can do. You can do it, but then if you want to support more than one platform, then you have to write multiple backends for compiling your language to native code. Now, it's not impossible. It's very possible. People do it all the time. But if you think about it, there's C compilers for everything. And you're going to get a lot further with your programming language if you transpile to C and then have any C compiler that, use whatever standard. I'm guessing that PreScheme is targeting like, is it even C89 and maybe ANSI C? So you could literally compile it with any C compiler, even ones that are 40 years ago. It's a bit better, I think, than depending on some library that does native compilation, to assembly language and stuff for you. Like I say, I'm no expert on that, but through all of my own study, this seems to be the thing. It's often more effective to compile to C and then let the C compiler do the dirty work for you than it is to try to write your own direct to native compiler. But JIT compilation is basically that in a lot of ways. So I don't know. I mean, there's LuaJIT. If you've ever seen LuaJIT before, it's a library you can embed into a program that can do just-in-time compilation of effectively Lua bytecode to native. So it exists, but maybe back in the days when PreScheme was created, it was more effective to change it to C and then compile the C compiler. Now there's more options. So you've got LLVM, etc. But really, LLVM is super bulky, and I don't know if I want to have to depend on the LLVM toolchain. Pretty much anybody who depends on LLVM is desperate to get rid of it at some point. So yeah, it's possible, but I just don't see it being the best option. Matthew says, "I'm no expert." Lol. Okay, yeah, sure. No, I'm no expert. I'm just being honest here, so that nobody will come in the comments later and say, "Oh, you were wrong about that." Well, yeah, I'm probably wrong about a lot of what I'm saying here. So it's great that you're correcting me, so that other people can go read the comment and get the right information. So thank you, it's great. Okay. Dave says, "I'm hoping for a self-contained compiler at some point where you don't have to deal with GCC or whatever. A WASM backend would be great." Yeah, it would be pretty cool. LLDM? What is that? I know that, I know that Hair, the language that Drew DeVault is working on, is using some backend called QBE. No, not QBE Insurance Group. QBE, come on, backend. Let's type it. QBE compiler backend. So it's another attempt at having a compiler backend that can do direct to native for various target architectures, and you're basically emitting a kind of assembly file that it will emit to a native binary. So there are options for this. I haven't looked at them because I'm kind of obsessed with the idea of compilers, but there's only so much time in the world, and I got to make YouTube videos, so what can I do? All right. I must have misheard the compiler chain nobody wants to use. Oh, LLVM. LLVM. It's a very big project. I mean, I think it's important work, but at the same time, like, it's kind of like industrial grade compiler middleware that most focused languages may not need. Even in languages like Zig. Zig started off with an LLVM backend, but then they spent like 2 years rewriting everything to have their own backend. And I think they're finally getting rid of LLVM. Zig, LLVM. I know I'm getting in the weeds here. Yeah, Fade says, at this point, LLVM is holding up Rust and Zig and C and C++. Well, Zig is getting out of there. They're getting the hell out of Dodge. I don't know when. When was this? Oh, was this the bootstrapping post? Anyway, if it's not now, it's at some point in the future. Judy says, I think they're still not 100% there, but they're pretty far. Yes, they've been working on it for a while. Okay, so let me check out. Oh, okay, so let me also give some more context about PreScheme. So this is a nice historical curiosity, Scheme 48 plus PreScheme. I mean, it's a really cool project. Everybody who writes Scheme kind of wants to have something like this. But who wants to use a project that hasn't been updated since, what year was it? 2014, I believe? Yeah, 2014. The last stable release was 10 years ago. Well, someone in the Scheme community named Andrew Whatson, who we've talked about on this channel before because he was actually the one who was maintaining the the Emacs PGDK builds in his own channel in probably 2021, 2022 timeframe before they were merged back into Geek's mainline repo. Well, Andrew has been dutifully working on restoring PreScheme to a more modern state to continue the project. There is a website called prescheme.org with more up-to-date information, let's say. We'll read through a little bit of this, but the point is that this project is now being funded, at least for some period of time, by the NLnet Foundation. So if you don't know about NLnet, which I'll have to give you some sad news too, but if you don't know about NLnet, it is a European organization that has been funding many free and open source software projects, including quite a number of Scheme projects, if you can believe it. They've funded a lot of things from the Sprightly Institute, like, I don't know if they funded Guile Hoot, but they have funded Guile Hoot and Goblins related projects, and including some more recently, like the one where they're going to try to get Sprightly Goblins baked into GNU Shepherd, right? The service daemon for geeks and for GNU in general. So they've been funding a lot of projects, and PreScheme is now one of them, which is really cool because this actually, gives us kind of a lifeline in the Scheme community to potentially have a scheme for systems programming that we can use to build other really cool and interesting things. So there was an announcement in June about this, and I believe that I talked about this at some point on whenever it happened, but they basically have given funding for this project. Let's see. We got Circlebon mentioned here. I'm looking for the actual information. Okay, given the rise of modern low-level systems languages like Rust and Zig, increased recognition of statically typed functional programming techniques thanks to the influence of Haskell, and I would also say OCaml, and the steady growth of a Scheme community interested in systems-level development driven by the Geeks project, seems clear that there is a latent demand for a language like PreScheme. I would say there's more than a latent demand. I think that people have been burning for a solution like this for years. Scheme offers an expressive and flexible language with good performance for general-purpose programming tasks. But there remain use cases where dropping down to a lower-level language is beneficial, such as when interfacing with external libraries. Well, I mean, building any kind of platform with Scheme, if you don't want to have to deal with a garbage collector and you want it to be really responsive, you kind of need, more control over memory management. So let's see. The primary objective of the PreScheme restoration project is to make PreScheme available as a practical alternative to C for the wider Scheme community, which would be awesome. This means bringing the PreScheme compiler to as many Scheme implementations as possible. That's an important thing. So we're not really talking about reviving Scheme 48 per se. We're making PreScheme something that can work on any Scheme implementation. So now you're basically trying to create a model for having any Scheme implementation be capable of generating native programs if they want to. So my guess is that, port this PreScheme compiler to a selection of R7RS compatible Scheme implementations. So if they target R7RS, which is the latest Scheme specification that is kind of half stalled. I mean, the small spec is done, but the large spec is kind of, who knows. But many up-to-date Scheme implementations do support R7RS to some degree. And I would imagine if PreScheme targets the sort of common surface area of R7RS across those, which I would think it could, because I would imagine it's mostly just syntaxes and some translation that just uses ports to write out the stuff. Now, I'm greatly oversimplifying what PreScheme probably does, but I'm guessing that it is not inconceivable that you could have a PreScheme library for R7RS that can be run in multiple Scheme implementations. So if you, Case says Scheme, so promising, so many pedants. Sure, I guess you're right about that. This is what happens whenever you have any kind of project that is focused on some idea of minimalism or purity. You're going to have pedants because everybody's arguing about what the limit of minimalism or purity is. This is just the way it is. That's how human brains work, especially on the internet with websites like Reddit or Hacker News. Okay? Where was I? Yeah, so basically, I feel like what PreScheme does is not really so specialized that you can't just have it be portable. So it's awesome that the goal is for it to be portable. Document the compiler architecture and develop an initial test suite to aid in further porting and regression testing, obviously needed for a solid foundation. Extend the language and type systems to support the set of size numeric types commonly found in systems languages. There's already some work there, but maybe it needs to be modernized somewhat. I've looked at the documentation. I'm not going to repeat what Fade said in the chat. Anyway, because these days, usually what you're seeing in systems programming languages is not like int, float, double, etc. You're seeing like, U16, U32, U64, F32, F64, these kinds of things. Like you're being a little bit more specific about the types. So maybe that's part of what's going to happen. I don't know. But there's also larger integer types now, like int 128. You get all like the SIMD vector operations that can happen in modern processors. So I don't know. It needs to be refocused on supporting all of that stuff that we can do now with modern architectures. Or Judy Dev says, or uint32t if you want more letters in your types. Don't you just love having to type out uint32_t all the time? I love it. Let's see. Complete support for some types or tag unions, which is really cool because tag unions are super useful. And implement syntax for algebraic data types and pattern matching. So tagged unions, if you don't know, other languages would call it like a discriminated union. It's basically an enum that can have data attached to it. So if you've used Rust before, it's kind of like the option type. Is it called option? Where it's like sum of something, some value, or none. Maybe I'm thinking of F# or OCaml, but the idea is that an enum is not just a flag. It's also something that can carry like a state plus information for each different state. So pretty useful, especially useful for more complex programs. Implement syntax for algebraic data types and pattern matching. Now I don't have a pithy explanation of what an algebraic data type is, but I think it's basically like describing type signatures. Someone can correct me on that in the chat. Let's see. Shipwizard says in the YouTube chat, I think NLnet gave some funding to GNU Mess or related bootstrapping project. Yes, and Akites, who's also in the Twitch chat, worked on that NLnet grant, I believe. So yeah, there's been a lot of GNU Scheme projects that have gotten funding from NLnet, which is awesome. I guess I should have said, I foreshadowed it, but I didn't actually get into that. I think that NLnet is going to lose its funding for future rounds because Europe decided, hey, AI is great. So how about we just fund a whole bunch of AI shit instead of giving it to, really worthwhile projects. Sorry for the cursing. I'm just a little bit upset about it because, whenever there's a good thing, someone always has to go ruin it. And usually it's with some hype like AI. So anyway, I digress. So replace the default string type with a linked prefix UTF-8 representation. You definitely want to have UTF-8 these days for sure. Revise other parts of the core language to improve R7RS compatibility and implement a standard library covering as much of R7RS and relevant surfaces as possible. Now that's interesting. Does that mean that we're going to have specialized versions of the most common surfaces and R7RS libraries that will be compiled down to C? That seems harder to pull off well, unless it's written in a way that gels well. Like, as soon as you start having const pairs, you have heap allocated data structures. And Scheme just uses the hell out of const pairs, so I don't really know how that's going to work. But maybe somebody in the chat, maybe Robin, maybe Dave, have some thoughts on that. Okay, implement a conventional command line compiler interface and an Emacs plugin to support interactive development. So, the way that PreScheme currently works in Scheme 48 is a little bit weird. It's basically a precompiled image that gets loaded into the Scheme 48 runtime, and then you have your interface. So I think the idea is that let's give it a little bit more of a front end to make it look more real and have it be a library that can be loaded up. Document the language, write tutorials, develop some example projects. I'm sure that many people would be happy to help with that effort. There is a PreScheme channel. Oh, no, that's not a channel. That's a tag. There's a PreScheme tag on the Fediverse if you want to follow that. There's also the Guile Steel channel on LibreChat, which I don't know if I was aware of that, so I'm going to have to join that up. But anyway, point being, really exciting project. It's really cool that Andrew has sort of taken on the mantle of restoring this to a more modern glory and make it available to scheme hackers to use as a basis for new and interesting work. Let me take a break and check out the chat and see if I missed anything. Ramin says, QBE looks pretty cool. We should have a QBE backend for PreScheme. Well, I would bet that you could write a QBE backend for PreScheme with PreScheme because it's probably a C library, or maybe it's just a program that's part of a compiler toolchain. Either way. Kay says, I actually found myself looking for a threading macro yesterday. Who am I anymore? Well, threading macros actually are pretty useful for functional programming. So I don't really think it's that bad. There's a threading macro in SuberX in Emacs. Do you know that? It has a terrible name, but if you look for thread left, yeah, you gotta pull in require suber-x. I think it's in there. Oh, I'm sorry, it's a macro, Control-H-O. Thread left, or thread last? Thread last, okay. I think it's thread first and thread last. It's a threading macro. So if you want a threading macro in Emacs Lisp, there you go. They're pretty common. In Scheme, you've got like cut and cute, which are, is that right? Scheme, cut, cute. Specializing parameters without currying. I don't know where the names came from on this. It's kind of strange to me. Am I right about this? Oh, no, it's not the same. It's not the same. This is like parameterizing a specific call. Anyway, I'm sure someone has the scheme threading stuff somewhere. Unless I'm thinking of something else. Case says, QBE is something I'm thinking about writing a Lisp targeting. Yeah, I mean, it's certainly an option for people who want to kind of bootstrap their own compiler toolchain. Fade says, type lures really need to look at Shen. I keep hearing about Shen. It sounds like some kind of mystical religion for Lispers. Actually, it's kind of like the fourth of Lisp. Am I being too reductive by saying that? Shen Lisp. The idea is that you have a very, very, very minimal set of core operations that kind of function as a machine of sorts, which I guess in a way Scheme kind of has that too, but it's not quite the same. And then you try to define everything else in the language with respect to that. I'm too basic for this. I'm just not going to waste my time trying to do this kind of ponderous Lisp development. I don't intend for anybody to take offense by me saying it's ponderous, but sometimes you got to really draw the line between something that's purely for navel gazing versus like trying to write programs. So I am very happy to receive all the hate and negative feedback about my comments on Shen. Gunn says fourth, the RPN language. Yeah, you know about fourth language. I don't really know much about it other than the fact that the basic set of operations is supposed to be very, very small, and it's easy to write a fourth interpreter or compiler. Am I right about that? Someone correct me. Anyway, it's another one of those languages. So there are all these, how would I even call it? Just like, they're basically honeypots for borderline autistic programmers, or maybe autistic programmers too, I don't know. Which I think that probably if you're here watching this right now, you qualify on some level, you're on the spectrum. And you just get this idea in your head, wow, it can be so simple. Wow, it's just that. It's nothing else. I have solved everything. The world has complete order now. I can express every thought and idea in relation to this core set of operations. I think we all have felt this desire at some point in our lives as programmers that we want to control the world through programs, but you can't do that, man. The world is fleshy and it stinks, and you're not gonna come up with the most perfect set of core constructs that is gonna save the world from evil. Kay says, uh-oh, David getting spicy in the chat. Big Evie says, way to insult your whole audience. I'm including myself in that statement. Okay, I am including myself in that statement. I'm not insulting anyone. I'm saying, all here, this is a safe space. We can admit that we get a little bit too hung up on weird stuff like this. And it's fine. I mean, it's a hobby, right? So long as you don't get a little bit too, stuck into it. I am speaking as a person who has done this many times. And I'm trying to tell you that I have repented for my ways. And I'm just trying to tell you what I've learned, Whenever you turn 40, you start to realize things in life, what's important, what's not, and maybe you become a little bit more pragmatic. But maybe when I turn 50, it'll be different. And I'll get really deep into some crazy stuff. Okay. Ramin says, yeah, I've definitely thought about coming up with programmatic core axioms for all of life and the whole universe. Still think that way about Scheme, actually. Exactly. And I know exactly what you're talking about. And it's not healthy. Not healthy. It's fun. And it's very, the hint of obsession from this kind of thinking is just, but can't do it. Robin says, another cool idea, maybe some compiler applications is linear Lisp from Baker's Look Ma, no garbage paper. I don't want to look that up because I think that's going to be a whole another can of worms in the direction that I was just describing. Okay, where are we? Once again, I got to pop the stack. And in this case, we've been using tail call optimization. So there is no stack, and I have no freaking idea where I left off. So, sorry. So let's take a look at the manual for Scheme 48. Here we go. Let's get right back into it. So this manual is up to date with apparently Scheme 48 1.3. Shom says, mesh really broke David Will. No, I just realized the dark side of getting too deep into certain projects and then losing your way out. You lose the thread that you took with you to come into the project and, find your way back out. It just disappears and you don't know anymore. Judy says pre-scheme. Yes, it's we're definitely off the stack at this point. So the manual actually does have quite a lot of information about Scheme 48, but we're not really concerned too much with Scheme 48 itself. There are some details about Scheme 48 that are relevant to pre-scheme, but we can just scroll on down to the pre-scheme section of the manual. Once again, pre-scheme is a low-level dialect scheme designed for systems programming with higher-level abstractions. For example, the Scheme 48 virtual machine is written in pre-scheme. Cool. It's a particularly interesting alternative to C for many systems programming tasks because not only does it operate about the same level as C, it may also be run in a high-level scheme development with no changes to the source. So another important point that didn't really come up until now is that pre-scheme actually is something that can be interpreted by a scheme runtime. So it's not just transpiled to C, it can also be interpreted. So what that means is, to some degree, you can do REPL-based development of pre-scheme programs in kind of an emulation environment in a running scheme implementation so that you can test things out and then compile it to C. So you don't have to do that whole round trip of compiling and testing, etc. See you, Shom. It's not getting above your pay grade. Come on, man. You're okay. I know you're just busy. It's all good. All right, so differences between pre-scheme and scheme. That's going to be useful. Number one, there is no garbage collector in pre-scheme, which sounds about right. If you want to do low-level memory management, you kind of don't want to have a garbage collector. I'm looking at you, Go. Pre-scheme has no closures. If you don't really know how closures work, so in a language like Scheme, you have lexical scoping, where a procedure defines a scope where bindings, basically variable to value mappings, can be defined. You can also define scopes within a scope and use bindings from the parent scope. That's effectively a closure. Whenever you define a procedure and then you create some bindings there to set some values inside the procedure, like you're assigning variables effectively, then you create another procedure inside that procedure and you return it from the procedure. So you're creating a higher order function in this case. You're making a function that returns a function that has been customized by the parameters that are given to the original function, etc. Somehow, the function that gets created needs to know how to get back to the values of the parent scope where it was created. And that's what a closure is for. A closure is an object that gets allocated on the heap, pretty much in every scheme implementation, to manage this mapping between this procedure that was created in a particular scope and then giving it access back to the original bindings that were available to it when it was created. So a language like PreScheme, which does not have automatic memory management or garbage collection, cannot have closures unless it's going to just do some really wacky stuff, which eventually would end up having to allocate memory on the heap. So you don't have closures. That's okay though. Closures are a super powerful aspect of Scheme. Those of you who have taken the Guile course, I talked at great length about procedures that create procedures and closures, etc. They are a core part of functional programming and building abstractions, but you don't need them, okay? You can get by just fine by creating structures that hold all the information that you want to pass around between procedures. It's just a different way of programming, okay? You're not going to be writing cute little Scheme programs with PreScheme. You're going to be writing you're going to be writing code in a slightly different style, and closures are not going to be part of that style, and that's okay. We can deal with that, all right? Just imagine that you're writing C with parentheses with maybe some of the nice things of Scheme, including macros and syntaxes, which are not terrible. So no closures. Let me read what's actually said here instead of just riffing on my own. Lambda expressions that would require full closures at runtime, e.g. those with those values that are stored in the heap, are not permitted in PreScheme. However, the PreScheme compiler may hoist many Lambda expressions to the top level, so it may enable you to have something like a closure, removing the need of closures for them. That sounds a little bit dangerous, but I imagine that they're mangling the symbol names in a way where it's not easily accessible from other parts of the program, so I hope that's the case. Closures would be much less useful in the absence of garbage collection in any case. Is that the order that I would make that statement? Closures would be much less useful. No, closures are useful, period, but you cannot have closures without garbage collection, I think, right? If the PreScheme compiler is unable to move a lambda to a place where it requires no closure, it signals an error. Okay, at least there's consistent behavior. Okay. Let's see. Tail call optimization is not universal. This also makes sense because you'd have to do some weird stuff like trampolines and other types of weird function signatures to enable everything. Robin says, sounds like lambda lifting. Yeah, definitely sounds like lambda lifting. PreScheme compiler optimizes tail calls where it is possible. Because this is more of a statically analyzed code base, I think they have a better sense of when something actually will be a tail call. Now, tail call optimization, at least in terms of the Scheme spec, is pretty clear which locations would be tail call sites. I guess it's not as easily clear for compiling to native, especially if you're compiling to C. That's one place where Scheme to C compilers always have trouble because you need to use something like long jump a lot of times to be able to jump to a procedure somewhere else in memory and not just like something that's more close by. Get in the weeds here, sorry. So you don't get tail calls in all cases. Typically just in local loops and top level procedures that are not exported from the package. So it sounds like local loops make sense. If you have a local loop inside of a procedure, you're writing it like a named let to do looping in that way, and you're not really like, it's not escaping from the function. Like you're not using a continuation, which I'm sure there's, yeah. So PreScheme does not support first class continuation, so that's out of there anyway. But there are kind of ways you can write named let loops that would be a little bit wacky, but normal local loops, I think, are going to be fine for tail call optimization because it's kind of contained within the bounds of another function call, right? And top level procedures that are not exported from the package, but there are other heuristics, but it's not universal. Top level procedures that are not exported from the package. So if they can isolate the place where the code gets executed, then it's easier for them to safely implement a tail call without it leaking some weird kind of control mechanics to the caller, I'm guessing. I don't know for sure. I'm just kind of like guessing based on what I've seen before writing a scheme compiler. Let's see. But in situations where the compiler would not have optimized a tail call, this can make the generated code have to jump through many hoops to be a tail call, often necessitating code bloat. Sure. Okay, whatever. Types are strictly verified with Hindley-Milner type inference. Hindley-Milner is kind of like the, would you call it the gold standard for sort of like, you know, statically typed programming languages these days? I know there's other stuff, like there's some category theory typing stuff, like algebraic types and whatnot, which are kind of outside the scope of Hindley-Milner. I'm not an expert. I just know that I've used a few languages that use Hindley-Milner typing. But it does give you pretty good type inference, which means that you don't actually need to annotate everything. Every function call or even function declaration does not necessarily need to have type annotations because they can be inferred through looking at the data flow through the calls in the program. So it's a way to have static typing without pissing you off with all of the required typing, right? Ramin says, Hindley-Milner is the type checking algorithm for System F calculus, I believe. Well, I don't know what a System F calculus is, but I know what an OCaml is. Ramin says, I'll bet you can have closures without a GC, like in C++. It can be stack allocated and exist as long as that stack frame exists. Oh, yeah. Well, you kind of end up having stuff like that anyway, even like C programs, you know. It's pretty common practice these days for C libraries to have you initialize a struct on the stack and pass it into a function call, and you're sort of like specializing the program as you go through the function calls by having these structs that you're passing through. Ramin says it's used by Haskell and OCaml. I believe it's also used by TypeScript. Robin's giving a link to Lambda Cube Wikipedia. It's on a different machine, so I can't click it. Is a framework to investigate the different dimensions in which the calculus of constructions is a generalization of simply typed lambda calculus. I'm too dumb for this, okay? When you start showing me a box with Greek letters on it, if it doesn't have grilled meat inside of it, as I'm accustomed to living in Greece, I don't want to see it, okay? I don't want to see it because I don't get it. What is all this stuff? Lambda P2, what is that? Okay. I don't want to have to think. I don't want to do math. I just want to write some programs, for God's sake. No offense. We're just doing what we do here. Okay. Full numeric tower of R5 RS is not supported by PreScheme. That kind of makes sense because you need to have scheme-style value types, I think, for this to work. So yeah, I mean, you don't really want that anyway because what you want is specificity on the numeric types that you're using, because otherwise it doesn't make sense. Top level PreScheme code is evaluated at compile time. Now that's a pretty important part. So what this basically means is that you can use conventional, I'm assuming, it means you can use conventional scheme syntaxes like syntax rules, syntax case to create abstractions that then can be converted into PreScheme code that gets converted to native. So you can create macros that are much better than what you could do with C. C macros are incredibly limited if you've ever tried to use them before. People have done quite a lot. In fact, I think Robin pointed out libcello earlier today in the IRC. This is a high-level C library, which is abusing the hell out of C macros to introduce some kind of like typing stuff. And yeah, I mean, that was interesting. I feel like you really, how is this to debug? Like, is it kind of impossible to debug code with this when it goes wrong? Like if you forget a parameter to something, are you just completely confused? Because C macros are not helpful. There's no way to get syntax errors very easily out of C macros. As far as I know, I'm pretty sure it's not possible. Scheme macros, on the other hand, you can have actual syntax errors that are contextual to the location where the error was found. So yeah, basically what I'm trying to say is PreScheme having access to full scheme macros is a big, big deal for writing abstractions in native programs. Software Tools says PreScheme doesn't have a garbage collector. No, it is compiling directly to C with manual memory management. Fade says, isn't there at least one C library that does high-level memory management in C programs? You mean like a garbage collector? I mean, there's like Boost and stuff, right? Boost, C library? Or is that a C++ library? C++. Anyway, stuff like that. Yeah, libcello does sound extremely complicated. I mean, it's cool. It's one of those things where you're like, oh, yeah, all right, cool. Yeah, you're really abusing what you can do with C, but I don't know, man. I think that that's going to be a real headache. Tim says, Milner is the guy responsible for ML, from which we get OCaml, Haskell, etc. Yes. Shitwizard says, the barbecue ramen brick actually is the lambda meat cube. I think we should actually patent that. Sounds good. I like it. Okay, now let's get into looking at some actual code and not just BSing around. Although PreScheme static type system is basically based mostly on Henley and Milner type inference with as little explicit type information as possible, there are still places where it's necessary to specify types explicitly. Yes, if you're going to call, they're saying you can get away with not annotating things pretty far in PreScheme code, except for when you need to start touching C APIs, which makes sense because you need to know what the contract is between PreScheme and the C APIs. So we're given a list of core types, which really makes sense. Like null, well, yeah, okay, null is void, float, integer, boolean, char, address. And then you have signatures for procedures, like with argument types and return types. So those are pretty necessary for having typing on procedures. Type of pointers that point to types. So we have a pointer type here with the caret character. Multiple value types internally used for argument and return types. So it's kind of like values for scheme. You can have a tuple type effectively. So they also have input port and output port, which is cool because you want to use ports in Scheme, and apparently PreScheme does actually implement ports in a way that looks like Scheme ports, but apparently is using normal C standard I/O. All right, standard environment. So I'm not going to read through this whole thing, right? We'll stop at some point, but we kind of want to see what's available to us and then maybe try the code a little bit. Judy says, interesting to see caret as pointer like Odin, but Odin is a lot newer. I haven't really looked at Odin very much. Fade says, I would expect this to come as a library of data structures, but I'm recalling something seen on Fresh Meat 20 years ago. Yo, good old Fresh Meat. So it may be a hallucination. Yeah, I'm still not sure if Fresh Meat exists or existed. I know it did. I had a Fresh Meat shirt, but I can't actually find an image of it on the internet. Okay. We have syntaxes for define, if, let, and, blah, blah, blah. The things you would expect to see. Define syntax and the other let variants of that. Current input port, current output port. I wonder how those are implemented. I guess they're implemented at the scheme layer potentially, because you kind of need parameters or fluids or something like that for those. Core operations, tail call optimization. There's a go-to procedure or syntax, let's say. So we have go-to in PreScheme. So if you don't like go-to, you can go to hell. Just kidding. PreScheme compiler can be forced to optimize tail calls, even those it would not have otherwise optimized. You're basically saying, I want this to be a tail call. In every respect other than the tail call optimization, this is equivalent to calling procedure with the given arguments. Many uses of goto may cause code to blow up if the PreScheme compiler had reason not to optimize the tail call. Yes, what you're telling the compiler is, I know you don't really want to do a tail call here, but you're going to do the damn tail call and you're going to like it. And when you do that, kind of have to expect something's going to go wrong. Bitwise manipulation, a compound data manipulation. So you have vectors, that's cool. More orientation towards static typing. So these must, okay, yeah, vectors in Scheme are not resizable inherently. So it makes sense. You're basically allocating an array. Can you have heterogeneous types though? Can't be, right? It would have to be all the same type. Statically type record facility. Okay, yeah, sure. Same as vectors in regular scheme, but with a few differences. Make vector initializes what it returns with null pointers. Oh, are this just like pointers? Hey, Peter. Vectors are statically typed. They contain only values that have the same static type as init. Of course, it has to be that way. Vector length is available only at the top level. So we don't have any like prefixed vector length attached to the allocated memory. What's a heterogeneous type? I'm probably pronouncing that wrong. Is basically like, I may be using the wrong terminology. Basically, different types. Types that are not the same. So let's see. Recall, so it can be evaluated at compile time. Vectors do not at runtime store their lengths. Okay, arrays don't either in C. It makes sense. I guess the goal here, which does make sense, is that if you start adding features like storing the length of a vector, then you're getting further away from raw C code, because an array in C does not store the array length inherently. The compiler knows what the array length is. It is a part of the type, but the array itself does not know how many elements have been allocated for that array. So for PreScheme to be closer to actual scheme and for vectors to be treated like arrays, it would have to effectively be an array in memory for it to work correctly. You could do some little tweaky magic to allocate an array of a particular type, of a particular size, and then like stuff, you know, an integer right before the beginning of it and then pass that around. But the compiler would have to do extra work to make sure that it's not passing the wrong offset at the memory location. So probably better just to be safe and not do something stupid. It does appear to me that when you use make vector, it's actually creating an instance of a type for the type of the init value and the length. So those are all encoded as part of the type. Like if an int array of length 5 in C is a type is int of length 5. I mean, that is what it is. Can't be anything else. All right. So make string. Strings in PreScheme are nearly the same as strings in R5RS scheme. Only 3 differences. Exactly 1 argument. Strings must be explicitly deallocated, sure. And strings are null terminated. Yeah. String length operates by scanning for the first. Okay, so string length is strlen. I wonder if it's implemented in the safe ways. As in C, there's no string balance checking at runtime, of course. So, you know, we're going pretty direct to C here. We're not doing any extra massaging of the intermediate code, it sounds like. All right, so we got a deallocate. Deallocate C memory pointed to by pointer. So you literally have a deallocation procedure. And then there is a null pointer procedure and a null pointer question mark predicate. So null pointer returns a null pointer, which I guess you kind of need, because you need something that can produce the null type as a value, right? Without having it be a special keyword. And I'm guessing that the compiler is not calling a procedure there, it's actually just directly translating that. Returns the distinguished null pointer object corresponds with a 0 in pointer context or null in C. Okay. Error handling. So there is some error handling. That's cool. Error code. So we're going to use basically enumerations. Enumerations are interesting in Scheme. I really haven't used them that much, and it kind of like flew under the radar for me. But enumerations are effectively enums like you would see in other languages, where you have a type called errors, and it has a closed set of values that could represent that type. So no errors, parse error, found not found, etc. So it's just a way to create an enumeration that sort of resolves back to a single type, right? Each enumerand has the following meaning. Sure. Returns a string describing the meaning of the errors, enumerand, and error status. So we're basically just seeing an implementation of errors for the PreScheme compiler using defined enumeration. I wonder if this defined enumeration is actually happening at the Scheme 48 level and not the pre-scheme level. I would guess it is. Probably it's... So whenever you're dealing with a language like this, I'm speaking as a person who has not done this before, but as a person who's thought about it a lot. When you're dealing with a language like this where you are writing a compiler for a static, or let's say a compiled to native language, but you're interpreting the code for that language in a higher level language that has a lot more power. You have to sort of like define the line between the things that are written in the interpreted language and then sort of used as the porcelain or the nice interface that gets turned into the stuff in the lower level language. So I don't really know what level defined enumeration is here, but I'm guessing it's a little bit higher level. I don't know. I/O, we have the typical port operations. Pre-scheme's built-in I/O facilities are buffered. Okay. There's no exception mechanism in pre-scheme. Everything's maintained by returning a status token. Okay. I mean, it definitely makes it easier to interoperate with C libraries if the general mechanics of pre-scheme code are similar enough to C. Kind of have to have that. All right, so let me see one thing real quick. All right. We got write char, write string, et cetera, et cetera. Okay, access to C functions and macros. Pretty important. I mean, if you're kind of would be a little bit weird and pointless to use pre-scheme to write a scheme program that doesn't actually call any C APIs. So we have effectively the foreign function interface through the external syntax. It's a special form for accessing C functions and macros. Calls in pre-scheme to the resulting procedure are compiled to calls in C for the function or macros named by CNAME. Now, I'm guessing that the generated FFI calls from pre-scheme to C are going to look way simpler than they look in other scheme implementations that generate C FFI, like Chibi scheme or Gambit scheme. Those, you got to do a lot of mapping between scheme types to C types, and there's just a lot of kind of bookkeeping boilerplate stuff that has to happen. So anytime you're interacting with the C API, there's kind of a lot of stuff going on. Here, I think that it's going to be a lot more direct, which I think is kind of awesome if you think about it. Like for a game developer, if you want to write something like an entity component system library, an ECS, maybe you've heard about that before. It's kind of like a database for a game that's meant for storing kind of like composite game objects, I guess you could say. And if you want to do this kind of thing in a native language, you often have to use macros or some weirdness to make it a bit easier to write code for that. But with a real syntax system or macro system in a higher level language like the post-scheme environment that pre-scheme would be using, probably do some pretty awesome stuff to write the abstractions for, or I guess the programming interface, let's say, for an ECS or something like that in normal scheme macros, and then turn that into pre-scheme code that gets evaluated and turned into C. So the performance of that code would be way higher, but you would still get the benefits of a higher level language like Scheme to make it really nice to write. Okay. I think that's good enough for now. Let's see. Record types. There are record types. They get turned into structs. Pre-scheme record types are translated to CS structs. You have to have a type specifier. Judy says, I think I misunderstood the premise. Does pre-scheme have a runtime component? I think there are standard libraries that might get pulled in. It's a whole program compiler, which I think is basically saying that there must be some tree shaking going on to pull in the stuff that you're using. So there's not really a runtime as much as like you're compiling in all the stuff that you need for the program into the C for the program. I could be wrong about that. Peter says, what are the compilation targets for pre-scheme? Anything that your C compiler can compile to. Judy says, you said FFI, but if it spits out C, wouldn't everything resolve to C? Yes. Well, the way that this language seems to be developed is to be as close to C as possible without any kind of like extra overhead. So you don't really need a runtime like, you have to deal with the boundary between the garbage collected types and the C code that might be touching those types. You don't really need all that stuff, but there's still like if I actually start writing some code, you'll see what it looks like. I've only looked at it a little bit, but you'll see kind of how the PreScheme code gets translated into C. It's simpler than a lot of other languages, but still there's, some stuff that needs to happen. So it's not really a runtime so much as it is just, extra boilerplate. All right, so multiple return values. We have basically multiple value returns. Low-level memory manipulation. You can allocate memory of a given size and just get it back as a pointer, which you kind of need if you want to do some C programming. Deallocate memory as well. It seems that the previous deallocate procedure we looked at before, it must be using type system information to understand what needs to be deallocated. I mean, obviously it has a pointer too, which when you go down to the C level, the C memory manager knows what the pointer refers to in memory and can deallocate that. But I kind of feel like there's a distinction here between deallocate as a procedure, which it is a procedure after all, not a syntax. I could be wrong about that. But there's also a deallocate, where was it? Deallocate memory, which also takes a pointer or an address. So the difference is a pointer is different than an address in this case. Okay. Unsigned byte ref. So we're getting into like the low level access to the native layer. You can do address arithmetic, pointer math, it seems. You can check comparisons on memory addresses. Cool. Copying memory. You can see if two memory addresses. Oh, the bytes. You can do a mem compare between two memory addresses given a count of bytes. Cool. So it sounds like C in the end. A lot of this stuff is just plain old C patterns, right? Andrea says, this is interesting. I would like to write a kernel with it. Yeah, I think that it would be pretty fun to write a lot of low-level stuff with this if it's sophisticated enough. Now, obviously, the state of PreScheme as it is in the last release of Scheme 48, which we will see in a moment, probably doesn't live up to modern standards, but that's why we have the PreScheme restoration project that's going to help with that. So we will see how that pans out as Andrew makes some progress in the project. Oh, calling the compiler. So after having loaded the PreScheme compiler, which is like basically a baked image that you pull into Scheme 48, the PreScheme compiler structure is the front end to the compiler. So you're initializing a structure. Sounds like. Yes, because you have struct fields that exports the PreScheme compiler procedure. So there's a structure and there's a procedure, both called PreScheme compiler. Okay. That doesn't sound like scheme to me. So copied specifies that each body of the copy procedure. We'll see this in a minute because there's an example in a second. Actually, example PreScheme compiler usage. Let's look at some code, okay? I've talked for how long? About an hour. Let's look at some code and try to compile some code. So the following code gives examples of running the PreScheme compiler. They are Scheme 48 command programs. That doesn't matter so much. Let's just look at it. So you do start with a main function. Okay, so it's typical C program. You got an int main effectively. This is a define that it's a main procedure that looks at the arguments. It will write out the first argument past the program. If there are two arguments, if there are not two arguments, it will write out an error with some usage information. So it's a very simple program. I think it tells us what the output is, but how about we just look at it ourselves? Because maybe we should try to write something at this point to really get the sense of what we're doing here. So let me code PreScheme test main.scm. Okay. I don't know if scm is the appropriate extension, but that's what I'm going to be using. All right. Can I? Okay. And it seems that we're returning exit codes directly. I'm hearing strange noises. It must be the police. So yes, the last value that gets returned from main appears to be the exit code for the program. So there you go. Now, we're going to try to pull up. Where was my shell? Eat. All right. I've got PreScheme here. Oh, and let me tell you how I got that. First of all, there is a package in Geeks, if you're using Geeks, which obviously you are if you're here. It is scheme48-PreScheme. If the Geeks repo will help me by starting. Robin says there's an OS effort based on PreScheme, the 3L project. That sounds cool. I'm going to just pull that up, 3lproject.org. Judy says, I wonder how it handles multiple return types. I suspect compiler error. No, it's got some stuff built in for that. So oh, you mean different types that come out? I've got some thoughts on how that might happen. We should try to take a look at it. All right, so we'll look at that another time. Do we have the Geeks REPL? No, whatever. So I pulled this up with Geeks shell scheme48-PreScheme. So if you want to use Geeks and run this, it actually is available to you. You can use it right now. The PreScheme command is kind of like the helpful entry point to running the PreScheme compiler. It seems that if I use PreScheme-I, let me go to projects code PreScheme test, PreScheme-I main.scm. Premature EOF when reading image file. Well, that's weird. Main image file is unusable. Did I have a check parens? I think it's fine, right? Interesting. Numerical argument is out of domain. Did I miss a parameter? I actually need to pass in heap size? No, it's got a default. Stack size? Do I need to pass in stack size? Let me look at what the instructions say, so I'm not being a total idiot here. Oh. I think I need to invoke the PreScheme compiler and not try to call into PreScheme directly. I think that, let me actually see what this is. So which PreScheme? Oh, hey, we're in eat now. I got to remember that. So let me go grab that and then hop over to this file. We are calling the scheme48 VM with the PreScheme image loaded. Okay, so it's similar to what we're doing here. We're running scheme48 with the compiler image, and I believe we need to use PreScheme compiler here in this way. So you can't just do it the way that I did it. Let me try this, compile.scm. We're gonna put this in here. What is packages.scm? Is that the, there's two things. Oh, it needs this other file too. All right, so let's do this too. So packages.scm, so this is another file that it appears to need. Now, what do we have here? We have PreScheme compiler, hello. Packages.scm is one file. There's also a hello symbol and an hello.c. Now, the structure here, we're defining a structure called hello. We're exporting main. I'm not sure how that happens. We'll have to look at the docs. We open, I'm guessing, the PreScheme standard library, and for files, we pull in hello. And is that like hello.scm? It appears to be. What if I change this to main? It might yell at me. We'll see. Main.c. I don't really care about this whole hello concept. PS test, I don't know. Loving these full text websites. Oh, you like the old style black on white texty output? All right, so PreScheme -I. There we go. PreScheme-I. We want to use compile.scm. All right, so let's do this the way that it's meant to be done. PreScheme. So in here, we're going to actually pass this in to the REPL. Assert violation, unbound variable carefully. PS test. Well, I don't. Oh, okay. Unbound variable. Makes sense. PS test. Got to be consistent. Let's try that again. Okay, comma Q doesn't work. Comma exit. What did I see before? Oh, premature. Unbalanced parentheses read. Where did I do that? Main.scm, is that line 3 or character 3? Seems a little bit wrong to me though. I mean, you gave me this code. Oh, haha. Well, the underscore could be an issue. So how do I get back? Can I go up one level? Pop. Proceed. Comma Q. Okay. Four. Now, why is it telling me a different thing? Maybe let's change this. Game. I don't know, man. So I'm gonna rename it the game because I have no idea why all of a sudden it's giving me these errors. I think you replaced the last print. Oh, did I? You could be right, Judy. So let's open up the new game.scm file because I'm an idiot. Yes, that's exactly what happened. Thank you, Judy, for catching my mistake. Okay, so I think I might have, okay, it might have worked. Let's see, main.c, here we go. Let me just open this up so we can take a look at what it looks like. That simple program that does some sort of reading of parameters of the program and then writing things out using a normal looking scheme port gets turned into this. So we have a long value for the main return, which is kind of strange, never seen that before. We have the PreScheme header being pulled in. Also, you know, typical standard libraries for C. We have a couple of file descriptors or file pointers, let's say, for two different output streams. Do we have two different output streams? Yeah, we have the current output port, current error port. So we got both of those. They're being pushed up to the top of the main. And we're really just looking at argc as appears to be a mangled local variable name. And it's just a straight comparison to 2. We are assigning standard out to the out2x local variable. So we're literally just writing directly to a normal C port. PS write strings. That definitely seems like it's coming from a PreScheme library. So PS write string is a wrapper, let's say, for scheme style ports to C IO streams, let's say. Also, we are using pointer math to look at the second index of the array, the argument array, and we're dereferencing that. Here we've got a block that defines and is sort of like creates its own little block to define the ignore line. Now, I wonder if that is for optional parameters. This must be how they are kind of swallowing the use of optional parameters. They define a local variable that doesn't seem to get initialized, strangely. And they call their psWriteChar macro, I'm guessing, because it's all caps. And then it has this ignore XX value here. Who knows how that actually works in the end? We might have to take a look at the header file and find that out. But this is straight up C code, right? This is not a whole lot of mapping between. Also, what you're seeing is that they're writing out strings like hello world. There's no translation between a scheme string and a C string. You've got a string literal here in the C code, which you don't see at all whenever you are writing scheme code that gets cross-compiled to C with a normal scheme runtime. So we already see that there is, I'm not gonna say a one-to-one mapping of lines, but it's pretty damn close. So, okay, let's say it's half. 16 lines for the PreScheme code and 33 for the C code, but really you've got some of that with the pre-declaration of the main function and the includes and some of the other sort of like pre-declarations of variables. So, so far, not so bad. Judy says, seems weird. I would have expected PS right care to be a wrapper defined around a variadic with PS right care. I would guess that variadic macros did not exist whenever PreScheme was created. I don't know when variadic C macros came into the picture. 99, introduced in 1999 in the C99 revision. So definitely not there when PreScheme was created. I'm guessing that must be the reason. So probably that's something that will change. I would imagine that okay. I think C99 probably should be the limit for C code that gets produced by PreScheme. C89 is pretty good too. I'm saying that right? There's a C89 standard? Yeah. No. C89 language. Oh, it is ANSI C. Okay. So ANSI C is probably the best target because it is the most universal target, but C99 would result in, I would think, better C code. Judy says, did C89 guarantee uninitialized vars to be 0? I don't know. I wouldn't. Maybe for essential types like that, maybe. I don't know though. All right. So let's actually try something else here. Is there a way to do an include? How do you do an include for C library? If we want to try to do Raylib with this, I mean, we're not going to get very far. If we can get a window up and something rendering, which is not very hard in Raylib, then I think we could call it quite a success. Temp Crap says, why not newer C versions? Because ideally, the C code that PreScheme produces should be able to run on the widest variety of platforms possible, which includes platforms that might require older compilers that do not support the latest versions of C. Now, that doesn't have to be a goal. That's just kind of like, if you're going to go ahead and cross-compile to C, you might as well get the greatest benefit out of it. But I don't know. Like there's a point of balance to find there that it's not my job. So I'll leave that up to Andrew and whomever else happens to work on the project. So number one, we need to include something. So include. Can I say hash include? Literal? I don't know, man. How do I just inject some C code into the output? Is it part of the type declaration? No. I mean, I like the fact that they're using their own type system and not some like hackneyed secondary type system to do the FFI declarations. So effectively, your FFI declarations are normal function declarations in this language. It just you have to use type annotations. So that's cool. But how do I do an include? Is that a compiler flag, maybe? Maybe that's a compiler flag. Let's see. There is the PreScheme-compiler. Integrate. Shadow. Header. Each header line is added to the top of the generated C file. Okay, so this is part of, where is it? This thing. So header include raylib.h. It's not going to compile now because I don't have Raylib pulled into this profile, but I will do that in a moment. So if I go back here to the compiler and run it more time, let's see, unrecognized define structure keyword package source. This is the wrong thing. Export main. Yeah, okay, so, okay, I put it in the wrong place. My bad. So let's just drop this back over into, it's actually in this thing that I'm pulling in. I wish I could load that. Maybe I can load it. I put it back into compile.scm. I think it goes structure spec, config file names, init name, C file name, command, ... Okay, so command is the last thing. I'll take this out, drop it down right here. And then let me just throw it in the REPL and make sure that that's going to work first. What did I do? Header is an undefined variable. Does it need to be a sub list or header line? Each header line is added at the top of the generated C file. Command arguments are optional. They are used only to optimize a compiled program at the programmer's request. Seems like they're supposed to be passed in line here. So I'm not sure why it's going to complain. Let's try it this way. Is there a load command? Let me type in help. Load file name. Load script file name. Okay, so load compile.scm. Okay, good. So we can do that now. We don't have to keep typing this thing in. Package.scm, test init, main.c. Main.c is the output, okay. And this is a whole program compilation, so we only have one output file. We don't have multiple because we only worry about one C program at the end. Curious that it thinks that header is not legit because, well, it is a, oh, okay. Is this actually supposed to be a list? Probably. There we go. Okay, so let's take a look at the main.c file again, and there is our include for raylib.h. Cool. So if you want to throw some shims in or header files into your output C program, it seems that's the way to do it. Now, I think if we just pull Raylib in, I could probably start just banging out some procedure declarations. Or how would that work? If I do a define on a symbol and just give it a type, where is define colon define? Okay. Name argumentless value. There does not seem to be type annotation. Wait, this is that's PreScheme. Let's just look at this section again. External. Oh, okay. So syntax, we define the C name, the PS type to procedure. So let me go into game.scm. I'm going to go up here and use, what's it called? External. The C name is going to be, let's go to examples. This is how you learn Raylib. You just go and look at the examples because they just give you all the code that you need, which is great. Let's just do this basic window. All right. Go scan down to the code. Init window. So init window. And it's going to take two integers, I believe. Yeah, integers. Int, and string. I believe string is the name of the type. Where do I have that pulled up? PreScheme type. So pair address. Now, yeah, so to make a string, the type is string, it seems. All right, so let me just put string here. String as the third parameter, and then what does init window return? I believe init window, if I look at the cheat sheet, init window returns void. Okay, so I think null is going to be the ticket here. So null, I hope. Now, let's see here. Where is that spec again? I'm looking for external. External, okay. So the PS type is the PreScheme type. I'll open up a little tab here. And then the, all right, so we, oh, okay. So it's an arrow first, then a sublist of argument types. So it's sort of like this, arrow first, then a sublist of types, and then the any number of return types. And inside of the program, I'm going to call init window 1024 by 768. Who knows? Hello from PreScheme. And that should, in theory, do it. I'm going to just take the rest of this stuff out. We'll leave it for now. Maybe we want to see how to write some strings. But let's see if it actually works. I wish it would remember what I typed. Load compiler.sem. Where's it compiled? Jeez. Load compile.sem. Use of macro doesn't match definition. External init window. Let me just double check what I'm doing here. Oh, yeah. Okay, returns a procedure. Apparently I need to bind that. All right, so define init window. Cool, that's fine. Probably not the solution to the problem that I just ran into, but that's okay. So init window. Use of macro doesn't match definition. External init window arrow. Oh, get rid of the commas. Get rid of the commas. Okay, so another little problem here. Yeah, thanks, Robin. I did not realize it at first, but now it makes sense. So use of macro doesn't match definition. External. So I'm doing something else wrong. Yeah, what's up with those commas? I don't know, Dave. What language do I think I'm writing right now? CNAME, PS type, procedure. Oh, init window might need to be a string. Ooh. Which should be a string. Thank you, Robin. That's right. 100%. It pays to read the docs, folks. But, you know, in my defense, there is literally no example of calling external in the documentation file. So I'll take that one as a draw. Load compile.scm. A known type name int. Is it integer? Maybe it's just integer, huh? Is that right? Integer. All right, fine. Integer. Integer. Cool. Unknown type name string. Well, that's true. It didn't tell me there was something called string, so maybe I just need to call it pointer char. Doesn't really seem right, but maybe that is what it has to be, eh? And there's no way to call it const, which might give me some compiler warnings. Load compile.scm. There we go. Main.c. Let's go check it out. So we've got a call to init window, and that does actually look like a legit call to init window. So we're making some progress here. If I were to compile and run this, now that I see this, maybe let's do a little build script so I can rapidly iterate in the remaining 15 minutes that we have here. So build.sh, because I hate makefiles. So first of all, we want to run PreScheme. Oh, and I haven't actually pulled in Raylib yet in my profile, so I need to do that too. PreScheme. Did it work when I did that in the command line a little while ago? I don't think it worked, did it? Numerical argument out of domain. What are you talking about? I wish there was a way to have it eval interactively. Scheme 48-I. PS compiler image. I mean, it's literally evaling that code. I don't know why I can't load it. And PreScheme itself does not have... What am I looking for? Command line parameters. Stack size in words. Like, I've never had to pass that in. Load image. Oh, that's my fault. It's an image file. It's not a scheme file. Okay, fine. Robin is correct. It's reading it as an image, not source. So there's no way to automate that at the moment, it seems, unless I make a scheme script which runs in Scheme 48. I don't know if Scheme 48 has procedures for spawning, but maybe let's just forget about that for now. We will just have to limp along for the moment and have a running REPL, which is okay, I suppose. Load compile.scm, and then we'll pop open a compile buffer. Do I have GCC available? I main.c game. Oh, game. Ugh. Yep. Okay, so let's back out of here. Got to get the right profile loaded up. Geek Shell, GCC toolchain is also called Raylib. I think this is Raylib, but if I can get the damn REPL to come up, I'll wait for a second. Let it download 49 megabytes, and then we'll get back to it. Judy says, maybe it accepts standard in. I don't know. I kind of doubt it, but you could be right. Let's go. Taking a sweet time, as always. All right, so let me get back out of this again. Geek search Raylib. So I can't get the REPL to load up. Pretty sure it's just Raylib. All right, cool. So we're gonna add that now, Raylib. Ooh, I need to have that in my MetaX compile too, probably. Now we got other dependencies to pull in. Geeks shell. I don't need Scheme 48. I just need GCC toolchain and Raylib, and then run it through GCC here. Okay. Oh yeah, sure. -I, not correct. No such file or directory. Which? Oh yeah, I'm in a completely different folder. Let's do this. Let me just try to rerun that. I want to just steal this invocation and run it from here instead. Get the right default directory. Include PreScheme .h. All right, so I do need to pull in the PreScheme package so that it does have the header file available. So Scheme 48 PreScheme. All right, so undefined reference. Oh, I need to add, let's see, where would that be? So /gnu/store/ come on. Come on. How many folders we got in here? PreScheme 192 lib PreScheme.a. So let's try that. Hope it works. L PreScheme, no such file directory. So is this getting configured correctly, I wonder? Because clearly we are pulling in a library. So there's some stuff that we need to bake in. Come on, I want this to work. Someone has a thought. Let me have it, because I'm not sure what's going to happen. I might have to do a little cheeky thing. Oh, package config, maybe. Do I still have that dired open? No, of course not. Let's leave it open this time so I can get access to it. Come on, come on, come on. All right, so PreScheme. Where is it? Share? No, that's just lib stuff. Include. We got some include. That's cool. Lib. Oh, package config. Okay. Man, That's the last thing I want to have to do right now is deal with package config too. All right, so compile. We're going to put in package config. I got to remember the syntax for good old package config. And I wonder, is that going to work to do a subshell like this? I don't think that's going to work. Damn it. Yeah, I need a script. Will that work though in the context? Yeah, I think I need to just have a script that I'm going to run. This little build script here. It's terrible. It sucks, but whatever. Game, and then package config. And you said C flags, PreScheme. Thank you, Judy. All right, so got that. And here, oh, I need to make sure this is executable first. Whatever. Let's pull up a little E shell. I could probably do it a different way, but whatever. Chmod x build.sh. Let's just try it real quick. Okay, fine. That's expected. Yeah, I probably need the libs. Well, I need both actually. So I go back. Try it one more time. We'll do build.sh. Okay, so gain, yeah, fine. Undefined reference still. Oh, package config. Did I not add it? No, I forgot. Maybe we have success. We'll see. Yes, it's doing something. It looked like it actually initialized Raylib. Usage game user. Okay, that's actually being printed out. Yeah, okay, so it didn't stay open long enough. What we need now, if the gods are with us and we can get this done, is to just get the basic game loop running, which should be much easier now. Yeah, I could probably do sh-c to do this, but let's just get it done. That's okay. There's many ways to do it. I'm too lazy. So we need okay, sure, set target FPS. If I look at the cheat sheet, do I have the cheat sheet pulled up? I need the cheat sheet. Cheat sheet. This is basically the API contract for the library, and so I need all of these functions defined as procedures. Let's just do a real quick tear through this, and I think we should be able to get it done. So game.scm, define set target FPS external, set target FPS. In fact, I have some of these already for Chibi, but I'm just going to go ahead and redo it. Set target FPS, that's an integer returning a void. So here we have integer and then return null. Okay, so that's that one. Presuming that it works correctly. Begin drawing, end drawing, both of these seem to be void void, so that's much easier. Define begin drawing, external begin drawing. The little arrow, I'm guessing it's an empty list and null, not sure. Let me copy paste here and get this done. So a little end drawing and another end. What else we need? Clear background. These constants. Oh, I don't know exactly what they are. So we need close window also, which does seem to be just a void void. Define close window, external close window. Arrow, null, all right. Constants are color structs. How did I do that in Chibi? I have a link here. Let's see, Ray White. Did I say white? Oh, I actually defined a struct type for the color. We could do that. We might have to do that. But let's quickly just get the other functions going first. I mean, we don't need to clear the background first. It could just be a mess. That's fine. So we have draw text. Oh, it needs the light gray too, doesn't it? you can pass in a U64. Do I have to like set the parts of the integer on that? Be nice if I could just do that. Window should close, returns a Boolean, I think. Window should close, Boolean, okay. So define window should close, question mark, external. Window should close. Nothing and then Boolean. Is that right? Okay, Boolean, cool. So to start with, can I do this as a let loop? We're gonna find out. You feel lucky the struct is just 4 uint8s? Okay, well, let's try to do an actual struct. I mean, come on. Got a few more minutes. We can try to make this work. Unless window should close. What is the code? It's begin drawing, end drawing. Okay, so here we go. We got the main loop, presumably working. We can at least compile the code and see what it looks like. We're probably gonna get stuck right here, but let's just see. How did I get back to this folder? Come on, come on. Where is it? Okay, whatever. Geeks shell. Scheme 48 PreScheme. We're just getting back into the PreScheme REPL. Load compile.scm. All right, so unbound variable unless. So we don't have the unless macro. Fine. If window should close. If not, window should close. Fine. Do a little begin here. Nope. I don't know if I can elide the false path, so I'm just gonna put false here. I don't really care. Or 0, sure. Why not? Oh, I also need to call it the loop again too. I want to see what this looks like, if it works. Don't know how to write uvar argc as a C type. I'm sorry, what? Oh, huh? I'm confused. So I think something about the type inference here is getting confused about what this function or procedure is returning. Return 0 at the end. I mean, I'm effectively doing that. But yeah, maybe it's just not picking up on it. Kind of weird. Same thing. It actually reverted the buffer though. Let's check out the main.c. Oh, it's empty. Fine. Don't know how to write uvar argc02f. What does that even mean in this case? Can I say not here? Or should I be saying this? What are the values for bool? I put the space between the file name and the extension. Did I do that? No, I changed something now, so the error is different for that reason. Let me check Boolean. Zero and 1? I don't know. I mean, it should only ever... Okay, equal. Value A, value B. Let's try it that way maybe, huh? Is there a false? What is... Oh, I gotta use the scheme type probably. All right, I'm being stupid here. If window should close is true. Is it gonna be okay with that? Load compile to SCM. No. Type mismatch Boolean injure while reconstructing the type of lambda argc. So something, it thinks something is returning false. So maybe let loop needs to return a 0 or something. It shouldn't matter though, because this is like a block. Reconstructing the type of lambda argc argv. It's definitely confused by the return type somehow. The begin can't have a value because it's going to defeat the tail recursion. Type problem error. Yeah, they need some improvements on the error details. Maybe this was too ambitious of an example to try to pull off here, but I would think it should work. I mean, this is Scheme, right? Maybe it's just not so sophisticated at the present moment. Same error, which makes no sense. All right, let me just take the loop out. This is my solution to everything. Comment things out until it works, and then work backwards. Works every time, 50% of the time. Okay, we're back to this weird thing, load. There's a unit type. Oh, is it unit? Is that part of the problem here? Unit. That's one value that's not strictly true. Yeah, I see what you mean. Yeah, I mean, it's... I'm not 100% sure. Don't know how to write. uvar remove the test and loop unconditionally. Will it figure it out? Still, it's got a problem, right? Like, I don't know if it's having argc argv here. I don't know if even, is that necessary? If I don't use it, can I just get rid of it? That seems to improve the situation. So if you don't use parameters, you don't use parameters, it doesn't know what the type is because it can't infer it. Makes sense. I did return 0 earlier. Let's see if it works now. Load compile.scm. Okay, so this is a different problem. I'm gonna return 0 here too because why not? Load compile.scm. Still the same weird issue. It's trying to reconstruct the type of the lambda itself. Probably wants EQ, you think? Oh, Judy. Judy with the win. Okay, so begin drawing in drawing loop. And loop is a separate procedure that's being, or separate function that's being defined, a static function, which makes sense. And then it calls itself recursively. Okay. Could be, Robin, could be. This is kind of interesting that it went that way. How's it doing the check? Yeah, it's checking for 1. Okay. That makes sense. So can I get rid of this? And this? I feel better now. I feel much better now. It's got to, oh, it changed now from a broken out static function to a goto. I'm okay with that. I mean, it's not the prettiest code in the world, but it's pretty damn minimal. Main void is allowed. Yeah. It would have to be allowed. Okay, so we're back into it. Begin drawing in drawing loop. So first we need to have a, and I gotta get off here, but I gotta see this through. So define struct. I don't know if define structure works, but define record type definitely seems to work in PreScheme. So let me try that. This is gonna be, let's just call it color. And what is the type descriptor in this case? Is it like no example? Type is mangled to the C-struct type name. And I'm guessing type descriptor is the scheme side name. Type descriptor name is unused unless running PreScheme as scheme. Okay. All right. So can I say like color here? Cannot allocate a sufficient quantity of memory. Constructor, blah, blah, blah. Constructor would be, doesn't like the syntax. Make color. And then RGBA. I think that's the way that Raylib has their color set up. So color seems to be RGBA. All right. Cal says, sax music reminds me of Lemmy in the bathtub versus Fingers of the Depth sketch. Lemmy in the bathtub. That's always a great image to recall. So let's see. Where were we? Field tag, field type spec. Shit. So, where's the color type definition? It's okay, U8. So what, 3 chars? 4 chars? R, air. Is that right? Char, field accessor for unsigned chars. Yeah, I don't know if I can say unsigned. Maybe it doesn't matter. Who knows? So field tag, field accessor. So color R, and then we don't really need a modifier. Let's just leave it off. So RG char color G, B char color B, A char color A. Now let's compile it and see if it works. So load compile.scm. Unbound variable define record type. So do I need to include something? ES record type structure. That's weird. Records must be deallocated explicitly when their lifetime has expired. Are these now heap allocated? I don't want that. Probably needs to include the structure module in the packages. Oh. Just let the memory leak for now. Yeah, well, that's the way I like to do things anyway. Is it called that? Where is the open? Open is not described here. So there's structure spec, config file names, init name, C file name. No, that's the wrong thing I'm looking at. New line before color would give better indentation. Probably so, yeah. Nikes. Is it this one? Import PS record types. Is that what it is? Oh, okay. Where does that come in? Open PS record types. Can I put multiple in there? Yeah, that one has an open PreScheme. I don't know if that actually can be changed. PreScheme compiler. Yeah. There's copy, no copy, shadow. But that's not the same thing. This is the PreScheme compiler struct. That's not the same as this packages.scm. So define structure. Here we go. Module configuration language. Package clause. Is there like open in here somewhere? open scheme foo bar. So can I just put that in here? Is it like another thing here? PS record types? Who knows? Let's go back to eat, I think, right? So come on. Load, compile the SEM. Oh, what about that? Judy is winning it all today. So struct color char RGB A. We have a struct. We might be able to use it. I don't know if I can stack allocate this though. It does not seem that I can allocate a record type on the stack. No, right here. Yeah, it's trying to allocate the thing. I wish that I could see how to do an actual struct. Unless it needs to be like a tuple or something, which would be very, very strange. Okay, so I don't have more time. This is all the time I have. So let's recap. PreScheme is a dialect of scheme a restricted dialect of scheme with static typing that allows you to basically output C code directly. You can see right here, this is C code that's coming from a scheme program. The C code is on the left, the scheme code is on the right. I mean, there's a lot of potential here. I think I would need to experiment with it more to understand the right ways to write PreScheme code that translates to the C that I have in mind for interacting with libraries like Raylib. But I think it's pretty close. Like John Moe says in the chat, so close. It was so close. We actually did get init window running. Windows should close and begin to end drawing. Probably a running too. In fact, how about I just try that real fast? So it initialized, but I think that Windows should close just must have returned true immediately or something weird, and I don't know. Point being, you can see that it would work. We just need to understand the right translation between scheme and C code. But the C code is super stupidly minimal compared to what you would see from transpilation of scheme code of like Gambit scheme or Chibi scheme stubs over to C. So that's pretty cool. That's really cool, actually. I would use this for more things, but you know, there's only limited time for projects. I would actually try to do a game jam with this though. If there was like a little bit more evolved version of PreScheme that Andrew's working on that kind of tightened up some of the aspects of it. The errors are pretty bad. Those need to be improved because they're pretty impenetrable. If I didn't have Judy here and Robin watching over my shoulder in the chat, probably. Let's see. Windows should close. Oh, you're right. I got the direction flipped. Okay, let's just do this. Yeah, okay, I can hack the C code, but that's not really doing it for real. Load compile.scm. This is not a good dev loop, though. I mean, obviously, we can see that. Okay, compile, run, and there's the window. So we got a Raylib window with the expected title showing in a nice 4x3. Thanks, Judy. Again, see, I am not an expert. I'm just a guy who's sitting here just trying things until they work and waiting for the people in the chat who are smarter than me to tell me the answer. So thank you to the people who are here and paying attention and helping me out, because obviously we would be sitting here for 3 or 4 hours until I figured it all out. Cool. So let's get back to the recap. It works, surprisingly, and the code is pretty nice. Like, the output code is cool. Yeah, next week on System Crafters, PreScheme, OpenGL Triangle. Let's not go that far. I mean, I could see it working, but I don't know. We'll have to just figure out the whole struct thing first. So I'm really excited about this. I think there's a lot of potential for this project if it is modernized in the way that Andrew has in mind. It will open the door to a lot of really interesting systems programming stuff. I think Peter asked in the chat before about like memory safety and things of that nature. I don't know if it's something that you could actually implement as part of syntaxes or some other higher level mechanism in PreScheme to do some kind of memory safety checking, but I don't know. I mean, somebody could probably figure it out, I guess. It's not really as much of a concern for me personally, because I don't really care too much about perfection when it comes to memory management, but that's because I'm not writing software for X-ray machines or laser surgery devices. So I'm okay with some crashes, but many people aren't. That's okay. So thank you all for being here today. I'm really kind of impressed with the interest in this. So maybe we'll talk about PreScheme again at some point in the future. Thank you to all of you who, the scheme experts in the chat who are here to help me out as well. And yeah, keep an eye out next week. I'm hoping the next System Crafters video will be out. That's my goal. That's my plan. We'll see what happens with that. And yeah, I hope you all have a great weekend. Until next time, happy hacking. See ya.